name is Lori Milliken, and this lecture is all about measures of central tendency and measures of variability. Measures of central tendency and variability are used when we describe characteristics of a set of data. When considering data, usually we want to know where the middle is and how spread the data might be. For example, when you take an exam, the first question you usually ask your teacher is, how did the class do on the test? To answer that question, the professor would probably give you the average score. Another question you might have is, how spread out are the data? Did people score similarly, or was there a wide spread in the grades? The teacher then might give you the highest or the lowest score to help you with that. Every research study you read should report a measure of central tendency and a measure of variability for the group of people being studied. Before we talk about these measures of central tendency, we need to talk about the normal curve. This is a concept that is at the root of all of statistics. The normal curve is a frequency distribution for some measurement that we're going to call x. A frequency distribution shows the number of scores on the y-axis, the vertical axis. So for example, in this graph, the most frequently occurring score was 20, because that is the highest peak of this curve. Fewer people scored 10 and 30, and the fewest people scored 0 and 40. For nearly everything that can be measured, if you measure enough people, the scores will begin to look normally distributed, with scores clustering around the middle and then tailing off at either end. Therefore, the characteristics of a normal curve are stated here. The curve is bell-shaped. It is symmetrical, meaning if you folded this normal curve with a vertical fold, the right and left sides would be the same. The scores cluster in the middle and are fewer on either side. And finally, the three measures of central tendency, the mean, the mode, and the median, are equal. They are the same number. So here are the measures of central tendency that we will talk about. The mean is the number that is the average of the set of data. The median is the score that holds the middle position of a set of data. It's also called the 50th percentile. And the mode is the number in the data set that occurs the most frequently. Let's talk about each of these. The mean is the most sensitive measure of central tendency because it uses every score in the data set for its calculation. So to calculate the mean, you add up every individual score and you divide by the number of scores. Usually the mean is most appropriate for ratio and interval data. These are data that have decimal points that can be positive or negative. Most of the things that we measure are either ratio or interval data. As I said, for the mean, every data point in the data set is used in the calculation. But because of that, it is influenced by the presence of extreme scores, and we'll talk about this in an example coming up. The median, on the other hand, is the score that sits in the middle, or it's also called the 50th percentile. That middle position means that half of the data fall above that person and the other half fall below it. The median is not affected by extreme scores. So if the highest score in the data set was 5 versus 500, the middle position still would not change. And we'll talk about this in a minute as well. The median is a measure of position. It is determined by the number of scores and their rank order. So to figure out the number that sits at the 50th percentile, or right in the middle, you would take all of your data for a particular variable and arrange it in either ascending or descending order. Then you would count the number of scores and find that score that sits right in the middle. That is the median. The median is often used for ordinal or interval data. Ordinal data are data that give you some order, first place, second place, third place. And interval data are usually data that represent categories. So sometimes researchers will code characteristics. So in your data set, all the males will be assigned a number 1, all of the females will be assigned a 0, or some other number. That is interval data. The median ends up being a better measure of central tendency when the distribution of scores is not normal, and we'll talk about this in a second. The last measure of central tendency is called the mode. It is really the least useful measure of central tendency. The mode is the most frequently occurring score, and so it is based only on one number, unless of course you have two modes, which is a bimodal distribution. But it doesn't give you very much useful information, but it is simply the most frequently occurring score. Now when the data are normally distributed, the mean, the mode, and the median are all the same number. They're all in the middle. The most frequently occurring score is the same value as the mean when you add up all the numbers and get the average, and it's the middle position as well. However, those three scores are not always the same. As we've said before, the mean can be influenced by extreme scores. And in this case, the situation is what's called a negative skew. Notice the normal curve is kind of bell-shaped. There are scores clustering in a middle position, but you have one long tail on one side. And the mean, the mode, and the median are not in the same place. This situation happens when you have an extreme score. In this case, the extreme score is a score that is extremely low. There is one or maybe two scores sitting way down at the left-hand side of the x-axis, the horizontal axis. The presence of that one or two extremely low score pulls the tail of that normal curve way out to the left-hand side. And because you have one very low value compared to the rest of the values, the mean is going to be pulled down toward that value. So this would be a situation where maybe you're in a class and the class took an exam and everyone scored in the 80s and 90s, but there's one person maybe who didn't show up for the exam, and so they got a 0. That one person with the 0 would be way far on the left-hand side of this curve. Everyone else is clustered up in the higher range, but when you draw the normal curve for this frequency distribution, you see it's not normal and you get a long tail off to the left-hand side. Well, if you calculate the mean of that data, you're going to take all of those 80s and 90s that everyone got in the class, but you're also going to be adding in the 0 score that the person who didn't show up got. And that's going to bring the mean down. But it's not going to affect the middle, the 50th percentile, because whether that lowest score was a 0, a 10, a 20, or a 50, it doesn't matter because the middle is still the middle in terms of position. We can have the other scenario where we have one very high score. So maybe you have a group of people you measure for a research study, and let's say you're measuring their cholesterol values. And the people you're measuring have pretty consistent and similar cholesterol values, except maybe one person who has a really, really high cholesterol. Well, that person, in this case, is sitting way on the right-hand side of this curve. That one person makes this very long tail in the positive direction. This is a positive skew. If you added up all of those cholesterol values and got the average value, that one really high cholesterol value would influence the mean, pulling it up toward that extreme score. The middle position doesn't change though, so the median stays put. And so this is how the mean can get influenced by extreme scores, but the median is not. So which measure of central tendency is best to use? Typically we use the mean. It's the most often measure of central tendency that you'll see in the literature. However, sometimes you'll see the median reported in cases where there are extreme scores. Another characteristic of data that we can talk about is something called kurtosis. And this leads us right into our discussion about measures of variability. So on this graph, the brown curve, the mesokurtic curve, is very similar to the normal curve that we've been talking about so far. But there are situations where the curve could be much more clustered or narrow and a little bit taller. That's the green curve, the leptokurtic curve. So in that case, scores are really clustered closely around the middle, and their curve is very similar to the normal curve that we've been talking about so far. But there are situations where the curve could be much more clustered or narrow and a little bit taller. That's the green curve, the leptokurtic curve. So in that case, scores are really clustered closely around the middle, and there are a lot of scores right in the middle, and so it makes the peak a little bit higher. That's leptokurtic. On the other end, you can have a platykurtic curve, and that's a case where even though the middle is the same value between these three curves, the data are much more spread out around that middle. And so the curve ends up being flatter and wider. Now the variability, or the amount of spread in those scores, is something that we're going to be talking about next. So measures of variability describe the scatter or the spread of scores in a distribution. Two common measures of variability are the range and standard deviation. So first, the range is simply the difference between the highest and the lowest scores. To get the range, you take the highest score minus the lowest score. And this tells you the overall spread of scores in a set of data. But it's not incredibly helpful because it is only based on two numbers. And so you have no idea what the range of that one number on the high side is an extreme score or if it is an accurate representation of the spread. The other measure of variability is called the standard deviation. This is used extensively in the literature, and unfortunately it's sometimes the hardest to understand, so let's break this down a little bit. The standard deviation describes the range of numbers within which the middle 68.26% of scores fall, and that is for one standard deviation above and below the mean. You can do two standard deviations above and below the mean, and then three standard deviations. And we'll talk about this in much more detail, but for now, know that the standard deviation uses all of the scores in the set of data. It's typically the most reliable measure of the sample's variability, and it's used very extensively. The formula for standard deviation is shown on your screen. S stands for standard deviation. You have a phrase under a square root bar, and the symbols are the little funny looking E means sum of. The X is an individual value in the set of data. The X with a horizontal line on top is the mean value for that set of data, so add up all the numbers, divide by the number of scores. The N stands for the number of values in the data set. So essentially what you're doing when you calculate a standard deviation is you are calculating the distance of every individual score from the mean. So just take a look at the top part of that division, X minus the mean. Every single X is subtracted from the mean, and then all of those differences are added up, sum of, and you divide by the number of values in the data set. So in a sense, you can think of a standard deviation as the average of the deviations. It's not quite a straight average of the deviations, but it's a little bit more complicated than that. You do have to square the differences, and you have to take the square root of the whole phrase at the end. But essentially, a standard deviation is looking at how far individual points lie from the mean. And some points are pretty far from the mean, and some points are pretty close to the mean. But you get the average of how far individual points fall from the mean. And now you should be aware that some points are higher than the mean and some points are lower than the mean. So some of these differences will be positive differences and some will be negative. because some are on one side versus the other side of the mean. But in general, the standard deviation gives you the distance, average distance of the scores from the mean. And so by definition, a standard deviation is a number that you get from that calculation that we just looked at, that when you add it to and subtract it from the mean one time, it includes the middle 68.26% of the scores. And so in this picture, what you're looking at is that regular normal curve that we've seen before. The position right in the middle, you can see the symbol for the mean, the X with the horizontal line on top. So the mean is in the middle. And then you have positions of 1 standard deviation above, 2 standard deviations above, 3 standard deviations above, etc. And then you can go on the negative side. 1 standard deviation below is the minus 1s, 2 standard deviations below is the minus 2s, etc. And so by definition, 1 standard deviation above and below the mean includes the middle 68.26% of scores. And this is true all of the time, for every set of data. And so we'll deal with some specific examples coming up in a second, but this 68.26% is a number that's associated with this normal curve. It's beyond the scope of this introductory course to talk about how people got this number, but you need to accept that this number is the number that's associated with a standard deviation. When you go 2 standard deviations above or below the mean, that interval includes the middle 95%, or 95.44%. When you go 3 standard deviations above and below the mean, that interval includes almost all the scores, 99.73%. So it is very rare for someone to score a value that's more than 3 standard deviations away from the mean. So let's take an example. Let's say the mean for a group for age is 20 years. So a sample of people were selected from the population, and they were taking part in some study, and the researcher recorded the age of the group of people. It turns out that they are an average of 20 years. And then when they calculate that formula for standard deviation, they get the number 5. Now it's important to realize that the standard deviation comes out in the same unit of measure as whatever the variable you're measuring is. So this is age, we're measuring age in years, and so the standard deviation comes out to be 5 years if you had the actual raw data in front of you. So let's just say this is the example we're going to work with. On the website I do have a sample calculation of standard deviation if you're interested. It might help you understand the concept a little bit better. So for this example, the group is 20 years old with a standard deviation of 5 years. That means that the score that is 1 standard deviation above the mean is 25 years. And the age that is 1 standard deviation below the mean is 15. And to get those numbers, I just took the mean and I added 1 standard deviation one time, and then I subtracted 1 standard deviation from the mean one time. And you get that +1 to -1 interval. So that means that the middle 68.26% of scores for this group falls between 15 and 25 years. You could just redo this and add another standard deviation to get 2 standard deviations above and below the mean. And then for that, this would come out to be an interval of 10 to 30 years that includes the middle 95.44% of scores. That's 2 standard deviations. And so this is most useful when people start comparing maybe one group to another group. So let's take this example for age and carry it out a little further. Let's say that group that we just dealt with, 20 years plus or minus 5 years, is compared to another group who is also 20 years old, but their standard deviation is plus or minus 10 years. So the people that make up that sample, their ages are a little bit wider, a wider range. They're more spread out. Maybe there's someone who's a little bit older and someone who's much more young in this group compared to group A. Group A's scores are more clustered around 20, so their ages are more similar. And in Group B, their age is a little bit more spread out. And so if you look at if you plotted them as a normal curve, Group B would be that group with the shorter curve and it's a little bit wider. It's a larger standard deviation. Whereas Group A would be, in comparison, a little more clustered and a higher peak to that normal curve. So now, it's important to remember that those percentages in terms of the percent of scores that are included in that interval, those percentages are always going to be the same. For one standard deviation above and below, it's 68. For 2, it's the 95. And for 3, it's the 99. But it will take a wider interval to include the middle 68% of scores when the standard deviation is a bigger number. So for Group B, it takes a wider interval to include the middle 68%. So that plus or minus 1 standard deviation is a wider interval. It is 10 to 30 years to include the middle 68% of scores. Whereas Group B, that interval to include the middle 68% is narrower. It is 15 to 25. The last measure of variability that I want to talk about is something called the confidence interval. It's a little bit of a different concept than what we already talked about, but it's important to talk about because a confidence interval is reported quite often in the literature. Whereas the measures of variability we talked about before, the range and standard deviation, they relate to the sample. The confidence interval helps us to understand how close a sample statistic is to the population. And this is most often done for the statistic that shows the middle, the mean. So we're going to talk about this relative to the mean. So if you calculate a confidence interval for a sample mean, you are estimating how close the population mean is likely to be. So a confidence interval estimates the range within which the target population statistic, like the mean, would fall based on a sample's data. You can specify a level of confidence, and therefore, and usually people talk about a 95% confidence interval. So when you apply this to, let's say, the mean measured in a sample, a confidence interval provides a band within which the population's mean will likely fall 95% of the time. So let's talk about this in a little more detail. So in this example, this was some information from a telephone survey that was done across the country, but I'm going to show you just some of the data from the state of Massachusetts. This is from the Behavioral Risk Factor Surveillance Survey, and this is about one question that was asked on this survey about the history of myocardial infarctions, or a heart attack. So 8,909 people who responded to this telephone survey were asked about whether they ever had a heart attack, and 4% of that group reported having had a heart attack before. Now I need to point out that the 8,909 people are the sample. They're a sample that's coming from the population, which is the people, all of the people in the state of Massachusetts, or maybe all of the adults at least. And so you have 8,909 adults selected from the population of Massachusetts. 4% of the sample reported a history of myocardial infarction. Now, if this sample was a perfectly randomly selected sample and they perfectly represented the population, well, we would say then in the state of Massachusetts, about 4% of people have had a heart attack. But we're not always sure if the sample actually represents the population. So this is where the confidence interval comes in. We can take this information from the sample and calculate an interval within which the population's value for myocardial infarction rate would likely fall. And so in the study they actually did this, and they got a confidence interval that ranged from 3.5 to 4.4%. This was the 95% confidence interval that was reported. So this means that if we were to select 99 more samples from the population, which is the adults in the state of Massachusetts, we would find that 95 times out of 100 samples, the percent of myocardial infarctions would indeed come out between 3.5 and 4.4%. So the first sample that was drawn was these 8,909 people. They had a heart attack rate of 4%. If we were to redo this survey 99 more times by selecting 99 more samples and then calculated or asked them this question about heart attack rate, we would find that about 95 times out of 100 the sample's heart attack rate would come out to be somewhere between 3.5 and 4, just about 4.5%. Another way we could say this is we are 95% confident that the percent of people reporting a heart attack in this state is between 3.5 and 4.4%. So this is taking information from a sample and making an assumption about the population. We calculate this confidence interval, and we have some range within which the population statistic should fall. So in summary, this lecture was about central tendency to answer the question, where is the middle? And we talked about the mean, the mode, and the median. The mean is used most frequently. The mode, the most frequently occurring score, is used the least, really. And there are cases where the median, the middle, the score at the middle position, is a better measure of central tendency than the mean. And those are cases where we know that there are extreme scores in the data set. We also talked about measures of variability. We talked about the spread of scores in a sample, and we can talk about the range, we could talk about the standard deviation. And also we talked briefly about a confidence interval, which gives an estimate of what the population's value would be based on the sample value.